we're going to add one more layer onto our concept of proof, which has to do with congruent parts of congruent triangles. If you're given two triangles that are congruent, what can you say about the sides and angles? We can say that the corresponding parts are congruent. So we already have some practice of naming our congruent sides and angles. I'm going to do the same thing I did in the other video of highlighting my vertices. So I have I can't read, that's K, matches with I, and then L matches with H, and J matches with G. And now I'm going to write all my different statements. So I could say KJ is congruent to IG. I could say KL is congruent to IH. And I could say JL is congruent to GH. So my angles that are congruent are K is congruent to I, J is congruent to G, and L is congruent to H. So that part we looked at when we very first started this unit, how to write those congruent statements. But this is your new friend. I won't say best friend. I feel like I always say best friend. But CPCTC is such a mouthful, but it is handy because otherwise we have to write out the whole thing and that's annoying. It's corresponding parts of congruent triangles are congruent. That's what CPCTC stands for. Congruent parts of congruent triangles are congruent. So when am I going to use this? I'm going to use it when I look at my proof statement in a proof, and it's talking about proving either segments are congruent or angles are congruent. I'm going to be using CPCTC, not just the triangle proof. How do I use it? You do your normal proof, and after your triangle congruent statement, which is where you're saying triangle blah 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 equals, or sorry, is congruent to triangle blah blah blah, that's when we're going to use CPCTC. So I have two really short proofs right here for us to look at. So I want to clarify one thing that's important with our given is as we are reading our given to go ahead and start notating it on our diagram. So it says given AB is congruent to DE. AB, DE. BC is congruent to EF. BC, EF, and AC is congruent to DF. So this one is really, we're not going to have to add too much. So we always start with our given, so we're just going to copy those three statements to our given. And AC congruent to DF. So that's our given. You can already say that the two triangles are congruent because they both have side, side, side. And so my last step in my proof statement said angle A is congruent to angle D. Once you said that they're congruent by one of our theorems, then you can say that another part, in this case A and D, are congruent by CPCTC. Congruent parts of congruent triangles are congruent. So basically we do our normal triangle proof we've been working on for the past two lessons, and then we add in the CPCTC to finish it. Okay, so once again, we start with our givens, mark things as you are told them. H, G, J, so that's this angle, is congruent to K, J, G. And I'm going to to erase those lines now that I've done that part. Then I have KGJ, so that angle is congruent to HGJ. So copy that given into our starting point. Now the next thing that's going to be helpful is that we have a shared side. So what side is that? That's going to be that GJ is congruent to itself. Now technically that means our vertices are changing because of basically the corresponding parts. And that's by the reflexive property. And now if I look at my two triangles, I can say that they are congruent by angle, side, angle. So now any of the other parts of the triangle that I haven't used so far are going to be congruent. But I want to look at my proof. My proof statement I'm trying to do is that HG is congruent to KJ.